So, trying to find a space for these. Alrighty. Y'all good. Okay, so what I wanted you guys to do for your mahia is really kind of straightforward and easy. It's because I want to show you guys how to use this document because you're going to be collecting results today. So you should be going to lesson number 4 on the dialysis practice practical. And you should be opening up the Google Sheet that says 2 bio, dialysis practical diffusion and GLK. You should each have your own copy of it because you should be each collecting your own data. Are we okay with that so far? Okay. So, you'll need your device today. The whole plan for today is to collect your data, and then hopefully you'll have time to do some analysis. So let's look at that Google Sheet and also the Google Sheets as well. So lesson plan is going to be really kind of short in a sense of the plan is for me to explain how to collect your data and how I want you guys to kind of get going on the report, and then you guys have the remainder of the period to collect your data and what was the other thing I was going to say? Start processing it. Cool? And then my plan is for Thursday when I see you guys is to just give you more time to wrap up this practice practical. I have set in the school holidays that we have 2 days for bio tutorials. It'll be the Thursday and Thursday and Friday? Wednesday and Thursday, I can't quite remember. I think it's Wednesday and Thursday of week 2. It's just to give you guys another chance to do the dialysis experiment. The other thing we can do is a gummy bear experiment, same idea with osmosis. So if you feel like you need some extra practice with practical investigations, do come in. Cool? All right, so our success criteria for today, we are working on number 2, thinking about those different types of cellular transports, in particular osmosis for this practical. And then the second thing is you guys are starting to work on that scientific method and that ability to carry out an experiment. We are basically working on items 4 through 8 on that checklist, which is all about that planning and collecting that data. We'll talk more about processing and the discussion on Thursday, and Mr. Hall will lead that. All right, so on our Google Sheets, there are 2 tables that we are creating. One table is looking at the volume of the liquid. So you have the substance in the tube, so sugar, water, that sort of thing. And then you're talking about the volume of the liquid before and after, and the volume inside the tube. Oh, sorry, the tube should be, I remember. This here should state if you have water in the sugar, sugar in the water, or water and water, sugar and sugar. Does that make sense? What you need to do is talk about the before volume. So your before volume should have been 50 mils. That's what you had in your cylinders. And then your before volume for what was in the dialysis tube. You should have had 15, but when you weighed it on the scale, you might notice that it was actually 12. So you can write 12 instead, because 1 milliliter of solution equals 1 gram. So just FYI with that. So you should be measuring it the before and the after. The other thing that we are going to be measuring is some observations. So did the cell shrink or swell or no change? So when you're looking at the dialysis bag, you get bigger, smaller, or no change. The initial mass is what you took yesterday, and the final mass is what you have today. What you're going to be doing is you're calculating the percent change in that mass. So you're going to be taking the final mass minus the initial mass, and then you get your answer. Then you take that answer multiplied by 100 and divide it by that initial mass. I think that's DE, yeah. Are we okay with that so far? I'll show you on the sheet and we can talk about it a bit more. Okay? All right. ladies? All right, so here's that biology. We're doing number 4, dialysis practice, practical. If we look under the instructions, there's lots of things there. The main thing I want you guys to open to collect your data is this 2 biodialysis practical. Now, these 2 are images. They are not actually entered into the Google Sheet. So just keep in mind, both of these are images here, and that's one, you see, another image. So you won't be able to type into these boxes. Now, the good news is we have provided one of the, what's the word I'm looking for? One of the tables for you. So Ms. Quigley has made one of these tables so you can easily already start entering, 50 mils we start with, and then what does it change to? Does it go up or down? Are you okay with that so far? Can we get off the phones? Can we stop giggling and talking to each other? Ladies, this assessment's worth 4 credits. I'm trying to teach you the skill sets that you will need for this assessment. One of which is going to be the data table. All right, Presley, off the phone. All right, so we have only given you one of the data tables. So what that means is you need to make this data table over here, and you can type it into the box. So making sure you're typing in 2 A, B, C, D. Did it shrink or swell? The initial mass, the final mass. And then when you are setting up your equations here, this column would actually be F. And you're taking the E column, the final mass, and you're subtracting that initial mass. Then, if we want to figure out percent change in mass, you take what the mass difference is, times it by 100, and then divide it by that initial mass. And that'll give you a percentage change. Are we okay with that so far? All right, it's going to be a while until you guys need to calculate all that stuff. Just be mindful that you probably want to start building your data table before you start doing the practical, so that way when you do the practical you can easily input your data. Do you guys want some time right now to make the second data table, so that way everything's ready to go? All right, I'll give you about maybe 5 or 10 minutes to get that data table written on your spreadsheets, and then I'll give instructions on what we're doing when you take your dialysis bags out. Okay, so what I want to talk about now is how to keep in mind when you are going to get your your measuring cylinders. So, if we're looking at step number 9, the next day, remove the bags. So you're going to remove the bags from your cylinders. Now you're going to need to run them under water and shake dry, because you're going to be putting them on the scale to figure out their final mass. Are we good with that so far? So wash and dry the little bags. Make sure there's a paper towel on the balance. Make sure that balance is 0, and then record that mass. The other thing you need to do is record observations about the bag and the measuring cylinder. So, what is the color of the liquids in both the bag and in the measuring cylinder? The firmness of the bag. The other thing you're going to be measuring is your final volume of liquid. So when you take out your dialysis bag, you're going to read the measuring cylinder to see how much water is in there, because it should either have been absorbed into the bag or released from the bag. So we should expect it to change from that 50 mark that you initially had. Does that make sense? Total volume-wise, if I had my bag and my solution in here, should be 65. 50 from the dialysis bag, 50 from the cylinder. Does that make sense to everybody so far? So you should be recording mass of the dialysis bag, volume of the solution that's still in the cylinder, and the last thing to do to double check your measurement skills is you're going to take your dialysis bag after you've weighed it, and you're going to carefully cut it open and put the solution into one of these 25 mil measuring cylinders, and you're going to read the volume of what was inside the tube as well. Does that make sense? So there's 3 measurements you're taking. The first measurement is the dialysis bag weight. The second that you're measuring is the volume in the cylinder. And then the third one that you are measuring is your dialysis bag cut open and the solution poured into the measuring cylinder to measure it. In theory, the mass that you weigh for your dialysis bag should be the same as what you read for your measuring cylinder. Because 1 gram of liquid equals 1 mil of liquid. Okay? So that's the data that you guys need to collect. And when it comes to cleanup, make sure all the dialysis bags get thrown into the rubbish. Make sure all of our cylinders are washed with warm soapy water. So I'll block off one of the sinks and make it just a soapy water bucket. And then I'll make another one as our rinse cycle. Sound good? You guys have the rest of the period to collect your data. So go start collecting your data. You're going to need these tiny measuring cylinders, so I'll bring those out. You might want the beakers as well. The beaker and then the measuring cylinder. You also might want a funnel to help make your life easier. It's all to you. Make sure you're putting that data into that spreadsheet. Cool. There we go. And then just you can be able to see what you're writing as well. It should be on the board. Awesome. Okay. So I'm handing over to Mr. Hall. He's going to explain to you guys what you should expect to see in those different dialysis bags.
Great. Alrighty, everyone. So I'm just going to start off by drawing the cylinder that you guys are working with today. So how we're using those measuring cylinders that we've just been using today. So something like that. And so you've filled them up with water or sugar. So you did both ways. That group over in the corner, just listening really quickly. All right, so you had your measuring cylinder, and then you had a bag in the middle of it. And so we did 2 experiments, didn't we? We did one where there was water on the outside. So I'll draw blue as water. And then we had our sugar in the middle. So I'll do this one first. So what we're looking at today is something called osmosis. Has anyone heard of osmosis before? Yeah, you've heard of osmosis? So just really quickly, osmosis is a type of diffusion, but it's looking just at the water. All right, so if you remember the analogy about the candle, so if you've got a candle over in this corner, there's a high concentration of candle over here, but it eventually diffuses out because that's just how things work. They go from high concentration to low concentration. So in osmosis, you can think about water concentration. So in your bag, in the bag of the sugar, there is still water in there, but it's a low concentration of water compared to the outside. So outside of the bag in the cylinder was a high concentration of water, if that makes sense. And so what we saw was this bag, it's not like a normal typical plastic bag, it's actually what we call semi-permeable. So that means it lets some things through and it doesn't let other things through. So if you tied it up correctly, there shouldn't have been any sugar coming through, but the water can still move. All right, does that make sense? So what you would have seen is if you left the sugar in the bag overnight, what happened was the sugar stayed in the bag, and some of this water from the outside, it actually went from a high concentration of water into the bag where there was a lower concentration of water. All right, so the water was moving into the bag. So if you'd done it right, you would have seen that the bag actually got a bit heavier, right? And then you can also do it, we did it the opposite way as well. So you had the other one where you had your bag full of water. And then on the outside was the sugar solution. And so knowing that water moves from a high concentration to a low concentration, you guys would have seen that the water actually went out of the bag. And so the bag got lighter, right? So it's all about this water movement. So I've mucked up the colors a little bit. It might be a little bit harder to see, but can you see that? So that water was going from a high concentration to a low concentration. That's just how it works. And so yeah, the key here is that the bag was semi-permeable, so it would let water move, but not the sugar. And so that's why the water could move against concentrations. Some of you would have seen that the water changed color. So like in this first one here, you had some of the brown come out of the sugar and out of the bag and actually leaked into the water. So if that happened, what probably happened was you didn't tie the bag tightly enough, and so that the sugar could actually move, it actually leaked out of the bag because you didn't tie it tightly enough. Other than that, yeah, the sugar shouldn't have been able to move if you tied it up tightly enough. So yeah, so I'll go into more detail about osmosis on Thursday, but the key idea here is just that the water was moving through the bag whilst the sugar wasn't. And so that's why the weight of the bag was actually changing.
And then your two control ones, the water one and the one that did, water and water, glucose and glucose, those bags should not have changed because they had the same concentration of water molecules. So that's why it was our control, right? So I don't want you guys to worry too much about this data. I expect it to be bad because it's your first practical. The main thing about this practical was two things. One, to teach you the concept of osmosis, and two, for you guys to practice your practical skill sets, your experimental skill sets. The main thing being your measuring, because you're going to need to measure on the actual assessment. You're going to need to be able to take that measuring cylinder and read it properly, so that way you have accurate results. So remember, with that measuring cylinder, you're going to eye level, where that level of water is, and you're measuring at the bottom of the meniscus. When we say bottom of the meniscus, we're talking about how that little, you see how the water kind of curves? You measure at the bottom of that section. Okay, so all of these things will be sources of error, and it's not a bad thing if you have error, because when it comes to the write-up for the excellence component, that evaluation is where you get your excellence points. So you can talk about where your mistakes happened and why was it then going to impact your results. Are we good with that so far? All right, I'm just going to hop over, if you don't mind, Mr. Hall. All right, so we have about 10 minutes left. I still see some measuring cylinders out. There should only be one experiment still set up for the person that was absent yesterday. So these two stations I don't think are anybody's stations or anyone's current stations, so please make sure you're cleaning those up. I'm not going to let you leave unless they are cleaned up. What I want you guys to work on then for the last 10 minutes is those Google Slides and the Google Sheets. So on the Google Sheet, you should have your data entered. You should be able to put in that formula to calculate your mass difference and your percent change in your mass. And you should also be working on your Google Slides here. And typing in some of that information about your hypothesis, the variables, that sort of thing. Remember, at this point here, you're going to stop, and from 14 onwards, you're working individually. So you're allowed to work in a pair up to 13. Is that okay so far? The other thing you need to keep in mind is that we've given you a class set of data to compare. And you guys will also need to input your data as evidence, but the only data I want you to put in is that % mass change, okay? So you have to do the calculations before you can add your class data stuff. All right, so you have the remainder of the period to get some of this done. You'll have all of Thursday to work on this. We'll teach a little bit more content on osmosis just to make sure that's nailed. I won't have this due until the end of the holidays, so you guys can have the holidays to do the practice write-up, because we can use this as additional evidence. So it's really important that you guys do the write-up and show me that evidence. So keep in mind that I have extended the deadline so you have the holidays to work on it. Sound good? Also, we will have 2 tutorials in the holidays. We can do this one. We can do one with gummy bears, just to give you guys some practice. All right? So hop to it, get some work done. Don't waste the last 7 minutes.